Yes. Okay. First, I present myself. I'm Bruno Boutin, and I am a JASP core programmer. And, so I program more the interface and the background of JASP, but not really the analysis. And Don is more the R programmer who builds the analysis, or some of them at least. And I will give you, my part will be more about the interface of the analysis, how to build them. And Don will give you afterwards how to build that in R. And yes. So it's the first time we give this workshop, so I hope it will be okay. Yeah, as I told you in the email, we were the last year, even before, we worked quite hard to make the possibility to external people to build, to contribute to JASP by adding some new features or fixing some stuff or adding some analysis. But we were, we knew that before it was quite hard to add an analysis. You had to be really a good programmer to do that. So what we did two things. First, we tried to make it easier to program in R and all the interface part. So that was a lot of work already. And the second thing is it was to make this dynamic module. That is, you can plug in a new module in JASP dynamically when JASP is running. So if you make a new module, then you can plug it and you see it immediately in JASP. You don't have to wait a new version of JASP. So this is the second stuff. So I will share my screen so that we can see what I'm doing. So as I told you that I send you a test module. Everybody can see my screen. Is it big enough? Yeah, it's readable. Yeah. So we added a new feature here that is a developer mode. And that with this developer mode, you can add a developer module. And why it's a special module? Because it will interact actively. When you change your module, it will reload immediately the change you made. So here you have to select where is your module here, and if you add it here, after some seconds, it should appear in your ribbon bar here. I hope it works. Yes, it works. So
can I just ask a quick question? Should we have JASP open and follow what you're doing, or just watch what you're doing right now?
I think now it's better to watch what I'm doing, because
okay.
I will give a lot of information.
Okay.
Yeah. Workshop is, I think I will mainly give you more of the information, and afterwards you can try a little bit. This module, how it looks like, if you have a look to the structure of this module, it looks like an R package. And you have the description, the namespace, like an R package, and here are the R files. That is for the translation stuff. That's for the unit tests. You will not have to do that yet. And that is, yeah, for the interface. And I will explain you what it is, this description in this QML. First, the description, it's here. So here it describes which analysis you will. Someone ask something? No. Okay. Here it describes just the module you have just loaded. And here I just say that yeah, I have two analyses. So you see that here. And what I told you, it loads it dynamically. So if I change something here, for example, I will say, yeah, it's my first descriptive. Then just react immediately and see, oh, you have changed this description. I will load the module again, and I will change. Well, yeah, and you see immediately your changes. So that's why it's called developer module, that you can see immediately what you are changing. Yeah, in this file, it's a QML file. I will explain you exactly what it is, what it means, QML, but here it's really simple. It's just to say, okay, I have a name which is called my module, some properties of this module, and these two analyses. I can add also, for example, a separator here. And that will make yeah, it will make a little line here. Just that. If you want a nice icon here, you can add that also, but it's called something else. And I have an example here. Oh, yeah. It's called the group title.
I'm sorry, in which program do you open the QML files?
Oh, here I use a Qt creator to open it. You don't have to do that. You don't have to have a Qt creator. But the Qt creator knows about QML, so it can give you more information about what is possible or not. So it will tell you immediately, hey, you made a syntax fault here. So
can we just do it in R? Basically,
you can do that in R, but you will not have this nice color. But you know that is a component in QML that is a property in QML. So but yeah, if you don't want to use Qt because it's quite big, quite impressive in the beginning, and yeah, don't use that. But it would be nice. Yeah, it's nice to have an IDE. It's called an IDE that recognizes QML, that you that can tell you immediately, hey, you made a fault here. You made a mistake.
And which ones of these descriptions are mandatory? Do I always need to give it, I don't know, like do I always need an author or like an icon or something? Or can I leave out some of these?
Yeah, if you don't, yeah, we can try. If I don't use an icon.
I mean, it's. So should this always have this structure? So if basically if I start a module, then I should always copy and paste this and just fill in my information.
I think it's the best is to copy. For example, what I did is to copy the descriptive module. So I would say just copy that. Then you have already the structure, how the folders are, how the description.qml is should be. And then you can already start like that. So yeah, if you don't have an icon here, then you don't have an icon here. So
Okay.
it's nicer with an icon. And what I did, oh yeah, I need these icons should be in the structure here. So here I've just one icon. So have a look. So here you have a nice title here also. So that is about the description.qml. Yeah, it's in fact quite simple. It's a QML file, but I will explain you in more details what it is now QML. Yeah, QML stands for Qt modeling language. Yeah, it's a Qt language, and Qt, maybe you know it, is the framework we use to build JASP. So QML, it's an interface markup language. A markup language is like HTML. Maybe you know that, HTML. It means that, yeah, you have some name describing what you are, what is inside. So here you have a group title. It means, okay, inside I will have a group title. Here I will have an analysis. So you just describe what are the objects here, and here there's some property of this object. If I have a look to an analysis here, but here. So the structure of a QML file, first you have to import some library. This Qt Quick library, it's the main library, the core library of QML, so you have always to do that. And to use the JASP control, you have to import them like this. So it's only what it means. And yeah, QML is can be quite simple. It's just, yeah, you say, I want a checkbox, I want here a checkbox, I want an input there. But it can be also quite complex because you want the layouts to be fine, you want some dynamically, to put some dynamically stuff. And in fact, JASP, the interface of JASP is built on QML also. But if you wouldn't know which codes we had to build to have this kind of buttons like that, it's a lot of code. In fact, it's all this this button is already 20 lines of code. So it seems so simple, but in fact, if you go to in details, if you want to have this nice tooltip like that, yeah, it's still a lot of work. So it's what we did when we thought, okay, we will use QML, but we will simplify a lot for the developer. And so we built some components and that encapsulate all the details you don't need to know. And it will make the work you mainly want. Yeah, 99% you will only need this component we built for you. And so just use them, and it will be also it will be displayed in the way JASP, in the look and feel of JASP. So that is also very important. We want that JASP looks like JASP. So if you build a new analysis, but you don't change the colors or whatever, no, it will use the color we use in JASP. and the letter type, and also all kind of stuff. And you see, for example, the one component which is a variables form build this whole stuff here, for example. And that is a lot of code, in fact. But for you, you don't have to know. You just say, I want a form with my variables. And you say, I have the available one and the aside one. And it builds this whole stuff for you with these buttons and all this selection stuff like that. All that is built. You don't have to do that yourself. Also, for example, here I have a checkbox. It's just this one, this checkbox here. But inside the checkbox, I have an integer field. And if you do that inside, just assume that, in fact, this field should be enabled only if this checkbox is enabled, is checked. So it's what you see here. Then this integer field is now enabled. So it's just such a kind of thing that many people want easily. So we thought, okay, we'll make that easier. We put that inside the checkbox, and then you get immediately the logic of it. So the QML is so it encapsulates a lot of logic inside. So you just use that, and it's this. You have a kind of tag here of the name of the object, and then the property inside. And this property, yeah, is just what is the name? The name is very important for you because it will be the name which is used in the analysis. So, for example, these frequency tables will be used in the analysis. This name will be used in the analysis if you want to know if someone has checked this button, and then it will be true or false. So that's done. We'll explain you later how to do that in R, but you know already the name you will use in R. It will be this one. So it's important to add always a name to all the objects you use here. And for the checkbox, just a label is just this one. It's quite simple. The ID, that is a bit tricky. In fact, most of the time you don't need an ID. I think I just. But you need an ID just if you want to make a reference of this checkbox somewhere else. For example, I want this checkbox to be enabled only if these variables, if there's some columns in this list. So what I can do, I use the property enabled. So you see my in Qt Creator, he knows already which kind of property has this checkbox. So he knows that, okay, I start with N, and you know, oh yeah, do you mean enabled? So that's really inconvenient stuff. So that's why it's quite, yeah, it's better to use Qt Creator in this case. So I say, okay, the checkbox should be enabled when these variables have some columns. So for this, I need to refer to this variable stuff. So I need an ID here. So that's why I put an ID here. And I say variables And I have a property of this list, which is called count. It should be greater than 0. So then it should be more than one thing. So if I do that, then I see immediately, okay, here it's disabled immediately. And if I put some stuff here, then it's enabled. And here I want to explain you a second really important stuff in QML. It's a declarative language. You see, I just said here, I want it enabled when that is bigger than 0. If you are used in R, to program in R, that is quite different how you do that in R. In R, you have to say, hey, each time the variables, something is changed, I want to change this checkbox. We call that an imperative way of doing things. It's you say, okay, I have some change, I have to do something. Here, it's a declarative way. You just say, okay, I want that to be my value of the enabled property. And each time that is changed, each time that this expression changed, this enabled property will change also. So that is a way of thinking for our programmer, which is a bit different. Because what I see is that people try to do the other way around, to say, okay, if that is changed, I want to change this checkbox. But don't do that. Just try to think on this declarative way. It makes the code easier to read also. So that's the second property of QML, this declarative way of programming. I can explain a bit more about these objects, these main objects we use in JASP. For example,
one question about so you have now enabled various .count, and if I want now split by, do I just do an and sign? So I want them to be both filled in.
Both, yeah. So yeah, oh yeah, that's a good one, because so here I need yeah, I have already my ID here.
Okay, perfect.
And this expression is in fact a JavaScript expression. QML works with JavaScript to calculate the expression. So here, if you know the JavaScript, you know that it is an AND command. Could have been an OR, like that. So if I do that, then either that or that, and then it is enabled. So and here you make so here it's react on two properties, on this count of the split by and then the count of the variables. And each time these two things change, this enable property will change also. And yeah, you can make really complex expression with 10 variables, 10 reference of other components. And QML will take care that each time it's changed, then this property will change also.
Is there
called the binding.
somewhere with all the objects and properties. So for example, a list of all properties of checkbox.
Sorry?
Is there a list of all properties somewhere, like an index or something? Because if I didn't know like that checkbox had an enabled property,
yeah,
then how could I find it?
How could you find it? I have made a document. It was in my email describing the main properties of this stuff. If I have it here, I think. Interface. I have to. Oh yeah. It's not here because the enabled component is for every component. It's a really general property. But the other properties are described here. Name label checked.
Yeah, that's super useful.
Yeah. So in this document, I try to explain all the properties of all these components. And I made a lot of change last time, so maybe I have to update this document also. Yeah. How to, yeah, for example, if I want to add a new assigned list here, the second one. So the idea is to be unique in the whole file. So that's why you say there you have to change it. So here it makes immediately this third component, and this single variable is true. Yeah, that's I think quite understandable. If I don't do that, then I have it's not single variable. You can make more variables in it, and the variable form takes care that it is yeah, that the height of the variables and the split to and split is the same as a available list. You can make that if you want a bit smaller or a bit bigger. If I want to be really big, do that. And now it's a bit bigger. So that is a preferred height. It's not the height, but the preferred height. Yeah. That you have to know that. It should be in the document. What can I explain here? Yeah, I explain you the name. It's really important for the options in R. The title, yeah, and yeah, this QSTTR function, it's important for the translation. That means all strings which have this function can be translated afterwards. If you forget to do that, it will not be translated. Well, because now it's possible to translate in Dutch, in German, and soon in Japanese. And some people are working to translate that, and they will see immediately, hey, there's a new string split 2. I have also to translate it. The subject columns, it's this icon you see here. it's suggested. That means, yeah, I can do the nominal, but in fact, it accepts also the ordinal, because ordinal can be thought as a nominal, but it will not accept scale columns. Yeah. So all this objects, this components, I explained in this document, and you can in fact look at one analysis in JASP and see directly how this QML file is made. And so if you want to have exactly like a t-test like this one, you want to have this, yeah, that is quite simple stuff, but how to do something like that, for example, that these fixed factors come here already. How to do that? Then you can have a look to the ANOVA.qml. In fact, I can tell you exactly how it works. If you have another variable forms, we'll make a new one. So variables 2, and that will be from variables. And here, per default, if you're in an available variable list, it says, yeah, if you don't say what do you want in it, it takes all the variables you have in your data. But here I don't want all, I just want the one that are in the variables. So you can say the source of this of the available will be the variables here. So if I do that, then it comes immediately here. And this source property, I made it quite flexible. You can have several sources. For example, you can say, okay, I want the variables, but I want also the split by. And here you need an array because you have two things. So an array, it's with a square bracket. So if you have that and this one, then it will come also here. You can have also other stuff like you would like, for example, the levels of this variable as source. So for this, you can say it's a bit more complicated way of. You say I have from the split by. I want to use the levels. Exactly like that. And here you have the female and the male. And it will change each time you change it here. So there's many kind of possibility as kind of source you can have. You can have several sources. You have You can have a source also with your own values. For example, you can say, I want yeah, because I have two objects, 1 and 2. So it has already 1 and 2 plus this gender. Yeah, I don't know why you would like that, but it's also possible to do like this. So there's many kind of possibilities to make to change the sources, and I made it quite flexible because with my experience of all these modules here, yeah, many kind of sources are used, in fact. So I do that very flexible. A source can be also used in a drop-down, for example. So you say drop and also I want the variables. That's smaller. So this stuff is here. It's also possible to say, okay, I want only the, for example, the scale values of this list. So that is we have to do like that. Type is scale. So now the other one is the scale types of this list. So there's many kind of combination you can have here. Is it clear for everybody? Yeah. Yeah.
Can I ask a very stupid question?
Yeah.
So does it does JASP change every time you save the QML file, or do you have to press another like command?
No. Because I use this
developer module. Mm-hmm.
Developer module just now detect all the change in the QML file, also in the R files.
Mm-hmm.
And if every time I change it, it will load it again.
Okay, so there's no special command, just whenever
just save
whenever you save the file,
yeah,
it changes. Okay.
And you see immediately what you are doing. So that makes life quite easier, I think.
Yeah, this is super nice.
That you know exactly what you are doing here. And also, if you made some mistakes, for example, you have 2 times named variables, for example. So it tells you 2 controllers have the same name variables. And then, yeah, that's a problem because in the R analysis, you will have 2 things which is called the variables. So you don't know which one it will be, you will be given. So it helps you also a bit if you make some mistakes. If you make a big mistake, like the syntax is not good, yeah, it gives you 316. Yeah, it miss such a bracket, so breaks with bracket. Yeah, when yeah. After what you have the section is just this stuff. Yeah, now I will talk a bit about the layout of this interface. Per default, what you see here, yes, I will remove some stuff because you don't see it well. You have a big variables form that takes the whole place. But here you have, in fact, two columns. This one and this one. And per default, JASP says, here it's set, but in fact, you can remove it. You have always two columns. If you see here, you have, in fact, two columns of controls. If you just want to have one column, just say one here. You see that this is now in one column. And the structure of the layouts, you have the form. Every analysis has to start with a form object. And afterward, you have the sections. It is this stuff. And afterward, you have the groups. What to say that here I have this group, one group, a big group here, and a second group, basic plot. So it's what you see here. One group, and this second group. And it makes that per default as two columns. But inside the group, I have another group. Oh yeah, here I have a checkbox. And inside this checkbox, I have two groups. And as I told you, these two groups are disabled by default if you don't check it. So, and it makes the layout for you, so you don't have to say, okay, which space between the groups should be. That is made by JASP and as a standard way. So don't change that, in fact. And make it logical. If you think, okay, all the stuff with the scatter block should be in one group, so put it in one group, and then it will be always there. Yeah. Some question about that? No? Yeah. And now I want to, because questions quick, I want to do to say a last thing about QML, which is quite important. QML encapsulates stuff. So here you don't see what is behind this dropdown, what is behind this variables form. What happens sometimes, in fact very often, is that you build several analyses, but this analysis use roughly the same stuff, the same part of these options. For example, no. But
I think the Bayesian one has been driven.
all this ANOVA use the contrast stuff. And in place of building this contrast stuff for each analysis, you can say, okay, I will make one file which have all this contrast, and I will reuse it. And I will demonstrate how to do that. For example, here, I have the charts here. And I have two things, yeah. Oh yeah. I have some charts here, which says which kind of chart types I want, and that is on the last section here. But in fact, this section I will use it the same way in my other analysis. So what I can do is say, okay, I think I did it already. Yeah, here. I will put a QML file which have exactly the same section. So I put it like this. So here it doesn't start with a form, it's a section. And what I can do is to say, I want to use this chart. For this, I have to import it also, because if not, QML doesn't know where are these charts. So it is on the same, what I tell you, on the same folder where I am here. So it will be here. I have added this charts.qml. So what I can do is to say, okay, hey, I don't have to write it again here. I will call it charts. So that is a new component, which is called charts, because it's the name of the file. It's called charts. And I just do that. And I get also my section here. And what you can do also, because sometimes you are nearly the same components between analysis, but sometimes it is, yeah, some options should be there in this case, but not in the other case. So you could add some properties. And then, so what you can do, for example, yeah, what I did is here is I have added a property. It's a new property I just add here. Enable chart type is true. And it's enabled or not this radio button here. And what I can do is to say, okay, I want in my QML for this analysis, I want it false. So that is not enabled here now. Did you understand that? Or is it too difficult now? I go too far. It's yeah, QML make it a kind of object that you can encapsulate. You can encapsulate stuff which is repeated somewhere else. But you can say, okay, it's nearly the same, but I want to change. I want to be able to change some stuff in this component. And for this, you just use the property. You say, I want to add a new property for this component. And you just do like that. Is it clear or? Yeah. So I think that's what I wanted to say about QML. I hope it was useful. I think Don now can explain you a bit more about the R stuff, and afterwards you can try yourself to play with that. Did you play already? Did you plug in this my module? Yeah. Okay.
Bruno, one question. Maybe it's too early for that question, but I already made some changes and I asked myself, how do I push them up? I'm not familiar with GitHub.
Ah.
Maybe that's a quick show. Maybe it's too complex to show in a minute, but that would be really helpful.
Ah, yeah. Yeah, because yeah, that's true. Yeah, if you want, because now I tell you about how to add a new module. But if you have an existing module and you want to change some stuff, yeah, this all the module we have now are in a GitHub here in a JASP stats repository. So they are all described here, and you can download them. You can and play with it. But if you want to make some changes, for example, in the t-test, what you have to do is to fork. Yeah, now you have to know a bit about GitHub. So for the one who knows about GitHub, what you have to do is to fork this submodule in GitHub and to clone it on your own computer. You make this change with your own clone, and you make a pull request to this submodule. Yeah, is it clear, Thomas?
Yeah, basically I understand this. It's good to know that I have to make a fork. I didn't know that. So how do I actually do this pull request? I've never seen that. Maybe you can show.
Look, you can do a if you have a clone. First, the way of doing it with us, we do first a fork. So that you have your own GitHub account. You make a fork to your GitHub account, and for example, I have my own. GitHub account here. So and I can go to the t-test here for ANOVA. And I made a clone on my own computer. I did it and I pushed it on my own repository in GitHub. And now I want to make a pull request. You just have to put this button. And but yeah, I didn't make a commit. I have one commit. I will not do that. But if you do a pull request, I don't know what I will do. Yeah, you have to say, I want to make a pull request from my own repository to the JASP ANOVA and to the same module. And we have only one branch, the master now, on the module at least. We have only the master. And you just create this pull request. And then we receive it and we can accept or not. We can,
very nice. That seems easy. Thank you.
Yeah? Okay. That it was something about, this was about GitHub. Yes, okay. I think now Don can go on with I have to make you.
Yes.
I have to make you co-host. If not, you cannot share your screen, I think.
Yeah.
Yes.
Okay. Can everybody see me or see the screen now?
Yeah.
Okay, great. Well, I'm just going to talk about the R part. So I'm going to install the module.
Don, do you maybe have your microphone on your headphones, because right now it sounds like it's very hard to hear what you're saying exactly.
I'm afraid I don't have that because I generally never use Windows, but it would be better for this presentation if I don't use use Linux. Maybe this is better. Maybe.
Yeah, it's better. Yeah.
Okay, then we do it like this. In the meantime, let's see. I have some data. Just gonna load some data. Yeah, so we have my module part. This descriptive thing already does like a lot, right? And I figured that it might be easier to just start from scratch, but just to give a brief overview of what I'm gonna show how to do. There's tables here in the output. There is some plots, right, that you can create. And these plots are actually inside a container that is collapsible. Those are the main output components I'm going to talk about. And what's also happening here behind the scenes is that if you add a new variable, that these two plots that you saw right here, they didn't change. They weren't updated, and R knew that it didn't need to do that. So there is some state of like what was there before and what is there in the next iteration, and does that need to disappear, yes or no, because it is being updated. And I think it's easiest if we just start from scratch. So we take descriptives and we just delete everything, right? We delete the functions, but this is the main R function that's called. It's this function because inside the description.qml we have a function with this name. So that's why it's this function. And if we save this and we go back to JASP, then it's loading and then everything is gone and empty because now the function doesn't contain anything. That's what you would get if you delete everything. Just as a simple example, let's make a table called scope options. And we need to pass it a couple arguments. So I'm creating it. So I'm going to call a function called show options as these arguments, the JASP results and options. JASP results here is basically the whole output in JASP. We'll put all tables in there, all plots in there, all containers go in there, basically everything you want to keep. And options is an R list that is basically just the, is it this one? It's this one. It's basically an R representation of what the user filled in let's say variables or whether the checkbox was clicked. So it's an R representation of that. So we need to actually define this function, right? And what I'm going to do is I'm going to say create JASP table. Then I give it a name. Variables as a name. We'll see why in a second. And if I just put it in JASP results, I actually need to assign this into a variable, then we should see out. So I call the function create JASP table, give it a title, and put it in JASP results. And that's about all there is. And if we do this, then the module reloads, and there's an empty table with a title. Now we can of course put stuff in here and that to make it a little bit more interesting. And we can do that in the following way. We'll say table add column info, and then we have a name, which is our name. We have a title, which is for now it's going to be the JASP title, you could say, and the type, which is going to be string. What we're doing here is basically meta information about this table. We're basically saying there is a column. In R, we're going to refer to this column with this identifier, our name, and in JASP, we want to show this name, and that its type is a string. It could also be numeric or integer. There's even p-value for p-values, but in this case, I'm just going to use string, and I'm going to fill this with what's the data. I'm going to put in here options variables. Right. So options variables again refers to this QML component, and that should be in JASP everything inside here. So if I save this, save the R file, then it gets updated again. And once it finishes updating, we'll rerun the analysis, and we see that we actually get this information back. That's just the simplest table there is, but it's just you know, to get an idea of how that works. So the first thing you usually want to do if you write an analysis is that you want to load the data, right? So in this case, there is this argument here, data set. It's not filled yet; it's just empty, and we need to actually say to or ask what variables we want to load. So commonly this is done by just writing a function, something like the data, which takes the options as an argument. Now, if we define this function, and sorry, I also take data set as an argument, even though it's null. That's just a common idiom for now, because we have to load this data manually, but ideally in the future we get rid of that. But that's just something you have to do. So we have data set, and if the data set already exists, we return it. And otherwise, we do read data set to end with as columns. I'm going to just say options variables. Right, so this is what it would be returned. So this is basically going to say to JASP, all these names and options variables, read them from start to end and return them to me. There's some more options what you could do here. You have that should be read as numerics, ordinals, vectors. That should just be all columns in the data set. You should do something with list-wise deletion for missing values and all that. But for now, that's not important. This information is there, but you could use it like that. But for now, I think this is sufficient. And of course, normally you do something with this analysis, with this data. And for now, I'm just going to say, I'm just going to show the head of the data set. Make a table that basically does something like data set, except I don't have data set defined right now, but that's what it will do. So then we would need to define this function. Again, just go to, like before, create the JASP table. Right. And then we're going to assign it to JASP results, just as before. This name is important. I'll get to that, but it makes more sense in the when we talk about dependencies. And I'm going to say table data. Yes. And this is a different way of assigning data to a table. The original way is like you assign a column in R, which I guess most of you will be familiar with. But set data is basically assigning a whole data frame matrix or structure to the table. Save this, and then we go back to JASP, and we should see the effect. So we get the head of the data set, which in this case is just, well, we can check it, that the first 6 rows here line up with the first 6 rows in this table. Now, that's all nice. So we can create some tables, we can load data. The next basic thing that you would want to do in an analysis is show plots, right? So I'm just going to do something very simple with histograms. This can, of course, be any plot you want there to be, but that's why. So I again define a function, JASP results, dataset, and options. This is a very common pattern. If you look at JASP code, then there might be some kind of model that was computed in addition to this, but in principle, the main function should not contain any logic. It just contains function calls that do things. So again, if we define this function, we do something. Then what I want to do here is I want to make a histogram, something like that, for each variable that we have. So this should look something like for var and options variables, and then maybe there's a data set. So this qplot is just a ggplot function that makes a very simple ggplot of some data. And if we do something like this, then it makes a histogram, just a convenience function to make a quick, easy plot. Now this would be a plot, but we again have a JASP structure that you need to put this into, and that's what you create with create JASP. So again, this thing has a set of arguments, has a title. So that's plot if it's an argument. Title is going to be the name of this thing, so the var. So in this case, this would be the variable, and that would make a JASP plot. Okay, now we could do the same thing that we did before with just assigning this directly to JASP results, right? And you would get something like JASP results, and then maybe the name of the variable, and then we assign the plot. We assign JASP plot, and this will work in simple cases. If we save this and look at the results, then they should more or less work okay, except that well, it didn't. It overwrote the same plot every single time, which is because I actually put apostrophes here. If I just use the encoded variable, then it should actually give me 3 plots, like because I have there's 3 things here in variables. Now we have for each variable we have a plot. But what I want to do here is I want to put these in their own little container, because you can't collapse this, and also for dependencies, well, you can collapse it, but not as a group. But also for dependencies, this is not an ideal way of doing things. If you want to show the same table or plot for like every x, well, it's very common to put these things all in their own container. So we can do that. Right? We can just type create JASP container. Title is histograms. Everything, of course, has title, and that's okay. And then we can, instead of putting this in JASP results, we put everything in the container, and then at the end we put the container inside JASP results. So this is basically adding one layer, or sorry, yeah, literally a container for the plots, and adding one layer extra to the hierarchy of the output objects. If we look at the result, we see I have this title here now, and we can collapse this as a one whole thing. And that's fine. Now, so far, I haven't really made anything very reactive on the input. Like if you click frequency tables, the whole analysis is rerun, but nothing changes, right? There's nothing that relates this option. If I click it to what happens in the R output, this is just how do you show something in general. But it might be nice that if we only want to see, let's say these plots, if that option is checked, right? So we need to know, okay, this was called frequency tables, and then we have a QML file where we have frequency tables, and this is the name of it. This is what we need to reference in R. So this is since it's a checkbox, it will be a logical value. So I have to say if option, not options, frequency tables, return. So exit that function, don't make this container, and all the things that come with it. If we do that and save it, then well, it's still there because it's checked. And if I uncheck it, it's also still there because there is no dependency management going on. And if you don't say that things should depend on a particular option, then it just gets thrown away. Sorry, then it just gets kept. So we need to say that this container and everything inside of it depends on a particular option, this one. So that would be container $depend on and the name of the option. If we do that, and we wait for it to load, it disappears. We click it, it's back again. We click it again, it disappears. That clear so far? Okay. So a bit more about this the state mechanism is that almost always you don't want to throw any output elements away. So that goes for tables, that goes for plots, because what you see now is that if I click something unrelated, well, is that all these tables, they recompute. That it goes very fast. Sometimes you see the spinning wheel here, and sometimes you don't. But the issue is that they were recomputed, and that's expensive, right? It may be a very complex model, or maybe a difficult table to create, and you don't always want to compute it. And the general idea of how we go around that is if we take, say this first table, that would be this options variables table. We first ask if it's not null, the element that we want to fill. So if this thing is not null, that basically means if it's already existing, then just don't recreate it. So it's there in the output, and the assumption is that it's still useful. Then, of course, this thing needs to have some dependency of when does it change, right? When should it be thrown away? So the setup for that is depend on, and then variables. And again, this name should directly refer to something in the Qml file. Now, if we save this and we go back to JASP, then load a bit, it refreshes everything, and now if we do the thing, then we see that the second table sometimes still gets a spinning icon, but the first one does not, because we only set up this dependency management for the first table. So whenever we click a checkbox, basically this statement returns true because there is a table, it's not null. So we exit the function and we don't remake this table. For this function, however, we just always enter it and we always create a new table no matter what changed, even though everything's the same, we remake the table. So this is another very sophisticated function in that sense.
How can I make it dependent on multiple options? Do I just use a vector or is it a second argument?
So for multiple points, you could just say a vector. So this and then the rest of the options. You can also do something more complex, which is what I actually wanted to go to next, and that is to depend on the values of options. So what we have in this container, right, is that you have multiple plots, and they all have something to do with these variables. But you wouldn't say that this whole container as a whole depends on the variables, because then everything inside of it is thrown away as soon as a variable changes. So what we would need to say is that this JASP plot, and then we have yeah, I need to create that. I forgot what argument it's called. Contains value, and then we make a list that says variables var. So the variables here is again referring to the thing inside options, and the var is an element of that list. So I'm going to say that this particular plot, which is created for connormal, it has the dependency that connormal is an element of this options variables. So that means that if we do this, this plot will not be thrown away if unless this variable is removed from that list. To make this pattern slightly more complete, we need to say something like, if this element of this container is null, only then do we actually need to create this plot, right? So if it doesn't exist, then we need to create it and set its dependency accordingly. If we do this, then we go back to the JASP and wait for the thing. Then as soon as we add a new plot, then the new plot was added to the bottom of the list. And it wasn't that all the other plots were recreated. No, the other plots were still in memory or still stored, and those are just reused. And that makes the interaction much more smooth than recreating every line. That's one way to make more complex dependencies. And again, this is a list, but you can add more things in here. This can become more complex. Can depend on multiple things. You can use other things in addition. So a combination of the general options, right, and that the option contains a value. So you can make this quite complex. It's often not the best idea to make this very complex. It's a better idea to make these things layered in a hierarchy. It is already sort of going on here, because whatever dependencies this container has are also implicitly dependencies for all these plots, right? So we don't have to specify that this frequency tables checkbox is a dependency here, because the JASP plots will be nested inside a container, and that container has that dependency already. That's a main thing about dependencies. Another thing that we are still doing here, if you look at this function, every time we enter it, we just check if that option is there, and then we just create a container, and that's not really good, we should actually check if that container already exists before we attempt to recreate it. So a more appropriate setup would be something like we assign the container the value of this thing, right, of what we put in JASP results. Now, if the container is null, meaning it didn't exist, then we create it. But otherwise, we reuse the old container. That's kind of important. Otherwise, the things would be recreated that are inside the container. And that would make for a nearly complete plots setup. And if we now remove things, then it goes quite fast. So let's check if we can actually see this. So we get to the next behavior here. Yeah. So what we see now is that as soon as we click this frequency tables, then it's thinking, and then everything is made. Now this is one way to set up behavior, that the analysis is loading, is running, and then at one point everything is finished. But it's much more, or depending on what, if you have a setup like this, where you compute things at one variable at a time, you can also show intermediate output already. And whether that happens or not, kind of depends on when you make this link. That you assign this container to JASP results, or whether you assign a table to JASP results for that matter. Because as soon as this object is put inside of JASP results, then occasionally JASP results will check how much time has passed and did anything change in the output. And if things did change, then it will just show an update already. So to nicely showcase what would happen, it puts before the for loop. Let's do that. Let's look at the results. We can look at it once it loads. Then, yeah, it maybe went too fast, but it does show the plots one by one. So it actually gives intermediate feedback on what is happening. Make it sleep a little longer. Then, yeah, it's now filling in these plots one by one as they are created. And this is much more sensible behavior, in particular when you have analyses that run for multiple seconds, and you have things that you can show in between. You can also do the same with tables. If you want to fill a table row by row, then you have something for a table. You could do something like table or add rows, and then you have a list of, well, in this case, would be our name, is options, variables, then first or something. I can put this in a for loop. Something like this, right? So that you could fill in a table row by row, and we do this, for instance, in many Bayesian analyses, where one row is one model. So then we take some time to compute a model. We compute the results for the model, and then as a row for a particular table, we put it in the JASP table, and then it's shown to the user whenever enough time has passed. Makes sense so far?
Do these plots always update when the data are changed? Because everything depends on data set. So if someone changes a number in the data set, do they all update?
No. So what is happening actually? It's a good question. I don't really. I don't think. But you can change the number in this data set by opening it, right? So I'm not going to do that right now. But I think what's happening then is that it just refreshes everything. So at the top here you have button refresh all. And as soon as you actually change data, then it just clicks that for you behind the scenes. That has the same effect as that dependency. Once we have actual data editing in the future, that might get a little bit more sophisticated. But for now, as soon as it notices that a value changes in a column, it will just refresh. So that would be.
But then everything gets refreshed, or only the plots that depend on that column.
We can test it, right? Yeah, then I need to actually make this somewhere.
I think everything is refreshed if the column is used.
Okay.
But if the column is not used, it shouldn't be refreshed.
Yeah, that's
Okay.
that would be the better behavior.
But that's
So I don't have to use or think about the data set dependency in the same way I think about the options dependency.
No, you don't have to worry about that.
Okay.
What is common though, in terms of reading the data, is that you make some kind of ready check, and this depends from analysis to analysis, because but there's usually some minimum information you need from a user before you can say, the analysis is ready to do, to do anything. Usually this means that the length of options variables is larger than 0, which means basically that the user filled in some variable in this column. But it can also mean, for instance, in like a sample t-test, that you have both a grouping variable as well as some other variables, right? Or like in a paired sample t-test, you need 2 variables before you can do it. So you have some minimum requirements before you can actually do anything. And it's quite common that then you define something like a ready, and you pass these 2 options with subfunctions, and depending on whether they are ready, they basically stop this one. So they would have to do something like this. If not ready, and with this pattern, you do create a table. So you do show the user there could be output here, but I'm still just waiting for additional information. And that's and doing it like this is a bit nicer than just doing that immediately here. Because if you do it here, then what you get is, well, in this case, it won't. I need to add targeting. So yeah, if you make an error and it's just an R error, not a syntax error, but like something that doesn't exist, then you just get a stack trace like this. If it's really a syntax error, then you get a bigger error. It should just be a message box, and reinstalling the module box or fixing the error should solve the trick. Try it again. And initially, it shouldn't do anything because this is still all there. If we now remove everything, it's still showing the head of the data set because that didn't have the dependency, so let's get it. So if I quickly add a dependency to this, then just depend on the options variables, something like that. And you would just get a complete empty result, which is not really nice, right? So this is not what you want to show a user. And yeah, at the start, you also see that, like, if you look at most analyses, they show like an empty table that is waiting to be filled as soon as there is enough information to actually do some computations. And this basically boils down to that for each data set or for each function, you could pass this argument. For the actual reading of the data set, you could also put it outside, right? You only read the actual data set if it makes sense, because you could show information. And that's more or less managing user expectations than it is actually that you have to do it this way, but it just results in a nicer feeling if you program it that way. Any other questions about this so far? Because I want to switch to doing this all in RStudio next without using JASP.
Yeah, one question. How do I know which R functions are already available in JASP? For example, you showed ggplot2 is there, but how do I know?
Yeah, it's a good question. In principle, since this works as an R package, what you should be able to do is, if you want to use a particular package, well, there's ggplot, right? That's why you can use it. And if you want to use a different one, you add it here to your list, and that should be sufficient to get it to work. And then the second thing is that if you want to call it, you have to use something like this. So package name, 2 colons, and then the actual function name, because we don't do library this, because that would be a very bad idea to put the namespace there. So instead you get something like this, right? So you could build it up like this. If you've built R packages before, you can also do like it's literally an R package. So all the tools that exist for R packages to make life easy, you could use for making a JASP module. So if you like Proxygen to do these things, not sure if people are familiar with that, but you could do import from ggplot. Well, ggplot. What's called Qml? Yeah. Then you would call DevTools document on the thing itself, on the module. That doesn't work because I don't have the right packages loaded. And then it would add to this namespace this for you, right? So you can use all these shortcuts, and if you would do something like this, then you don't have to prefix this here. Then it basically tells R for this package, this sort of is a known symbol, and it refers to this package.
Can I also check it like a package? Like
yeah. Yes.
And I guess those checks should also run without warnings. So before I make a pull request or anything.
So we're not as strict as the RCMP check, if that's what you mean, because we just need to clean up some stuff before we can reach that level. But what you do have is that inside tests, there is a test.dat folder, and there's just test.dat file, which is similar to usual testing of R packages. It has all these tests, and it will just run them and compare the results. And this would be the next step of package development, to actually understanding what's going on here, right? That's what I wanted to look at next. Because it's possible to run all these things just in plain RStudio if you have, you need to be able to build R packages from source. That's about the main requirement. To do that, you need to remote install GitHub JASP desktop JASP tools, which installs the JASP tools package. Using the library JASP tools, it may tell you that there are upgraded versions which you may or may not want to use. The first time you do that, you can run setup JASP tools, and that starts an interactive menu to get your computer up to date with the minimum requirements to actually run this without JASP. I'm not going to do that now because it downloads some things that may take a while. But once you've done that, you should have inside your a folder of your preference, you should have something like JASP files, and I also have JASP desktop, but you wouldn't need that. It would actually do all that for you. Once that's set up, we load the package. We have some package options. This is, in this case, I'm going to say where are my modules. So initially, package options are referring to, where can it find HTML files that JASP uses, where are some data directories, where it can find data sets, the R packages it should use, whether it should use English language or something else, some other things. But the important one is module.dirs, which is module directories. And in this case, I set it to the location of where the top level directory of this module. So basically, this one, which is for me, it's here. But it can be anywhere you want it. Now, as soon as we did this, we can call function analysis options. Descriptives, where descriptives is now referring to this file actually. Not sure if it's case sensitive, but anyway, as soon as we do this, then we have basically an R list, which contains for each option the user could give the default value. So we see frequency tables is false. Other things are false. The integers are filled in. The color palette is fully chosen, and this is literally what would be sent to R in this options here as soon as someone clicks something in the user interface. And using this, we can actually run the analysis locally in RStudio. If I assign two variables, qnormal and qgamma, which are the same variables as in this dataset I have here, the debug dataset we always use. And then we can do run analysis with the name of the analysis, data file, and options. Debug.cc is sort of a standardized debug dataset, and JASP will always be able to find this. That's why we always use this. But you can also specify just the data frame if you have something loaded or a path to a file. And if we do this, then we get an error, which is not good. And try it again. That's better. It's installing the module from source, it's running it, and then it just shows the results right in RStudio in the viewer. It doesn't show the plots because I didn't check the plot checkbox, and if I would want to do that, I would set it to true, and then if we redo this, then it's just running it, and then we get to this output as well. And this is more or less running it locally, and this can be very useful to do things like debugging, because this is just running our code the way people might be used to. And if you develop packages before, then this might be a bit more familiar to you. Just take a bit more work to set up. I do think it has some benefits. And in addition to that, if you look at these unit tests I just showed before, and you see that this is basically the same structure, right? It gets the options from JASP analysis options, then it specifies some options, it runs the analysis, and then it actually retrieves the data from results, stats, data. Stats is the name of the table, and then data is actually the values inside that. And then we just test if these two obtained results are similar to the hard-coded results here with a particular error tolerance. That's more or less how to run that in R. You could also run these tests locally, of course, but test all and test analysis, where you would do something like this. Since I deleted most of the code in the analysis, this will just fail completely. So let's not do that. What we can do with this, just to show the interactivity, is that if you want to actually debug something, you're not sure why things go wrong, like browser here, which is basically once R reaches this, it will just stop and start an interactive session. And if we then run this, then it has the same issue again. Something with the packages in my system that are and it stops at this point in the R code. And now we can actually look at, well, everything again. But we can also go to the next line if we click here, or we can then evaluate statements. So I could select this and look at what's in here. We can go to the next line. The next line could use this one to step into the function. And when you enter that function, then you can actually debug line by line wherever something goes wrong, which may be useful because if you do it interactively with JASP, it may seem like a lot of code at once. And this allows you to sort of do this in a more, easygoing way. You want to stop at a particular moment in the code, and then you can just say, stop there, and then look at what is actually inside this particular object that makes things go wrong, right? And yeah, that's more or less what you can do with that. I don't want to go too much into the actual unit testing procedure because I think that there's some documents about that, and if you're familiar with that, this might not be the best time to start with it at all because it's slightly different from how it's usually done in R. But what I do want to mention as a final thing is that if we look at the original code of the is that we see in many places, let's give an example, script is table, yeah, is this thing, this get text. This get text is the analog of the QSDR in QML. It's just there to make translations possible. So what I should have done here in all of these tables is actually type get text, because then it will look up this string in a hopefully translate document, and if the language is set to say German, it will look up this string in the German document and load however it was translated. And by default, it's a good idea so that every string that is shown to the user, every string literal has this around it, so this one too. And if you want to make more or less more complex strings, right? So say I would have wanted to have a title that's not just a plain string, but where you would normally do something like I don't know, we would normally do paste. Make some up here variables. So the first one, right? So we paste this name and the first column name of the data set together. Then you would have to change that to use instead of paste, you would have to use sprintf, which is for text interpolation. This is just an R function. So if you go to the help file, you can use C-style string formatting commands, and you have some explanation and examples. But what it will basically do is if you have a structure like this with %s and another argument, is it will just replace this %s by that argument as a character. And the translated version of this is get text. All these functions are distant R, by the way, so you can just do something like question mark get text if you have if you're wondering how does this work, I want to read something about it, I want to see some examples. There is some whole explanation about this, just the base R. And yeah, the examples particularly are quite useful here. What is and is not possible. That makes sense? Because then I think I went through everything I had to say. Are there any questions? Okay, in that case, I think we discussed everything so far. Hopefully, this gives you a rough idea of how to set up a JASP module.
I think it was a lot of information.
Yeah.
Yeah, the best is now that you play with it, but all that. It's recorded, so you can, if you miss some point, some part of it, you can see that again. And yeah, ask us if you have some thing you didn't understand or you want to make some more difficult stuff. Don't hesitate. Yeah. Thank you. Yes. Okay, then if there's no more questions, and I think we can finish that. Yeah. Okay. Thank you very much. I stop the recording.